All right. Good morning, everyone. Or whatever time it is, if you're jet lagged like me and your body can't work it out. So I'm going to be talking about the app developers Kubernetes Toolbox, which is just a point of phrase that I termed to just talk about tools in Kubernetes that you can use for development. I'm not an artist, but I'm pretty proud of that thing, which took me probably 20 minutes. It's probably too long in Google Slides to get that going. I think it's cool. So my name's Adnan Abdulhussein. You can follow me on Twitter, GitHub, Slack, whatever, at Pridonius. I'm a software engineer at Bitnami, or soon to be VMware. And really, I'm kind of all about DevOps and development tooling. I love open source software, and that's kind of why I'm here talking about this today, because a lot of that kind of fits into there. And in the Kubernetes community, I am a co-chair of SIG apps. So if you haven't heard of SIG apps, it's, well, Kubernetes has SIGs, which are special interest groups. One of them is SIG apps, which is all about applications. And it's where people, either developers of application APIs inside of Kubernetes, or apps in the ecosystem, or just users of Kubernetes go to talk about how to run applications and operate applications on top of Kubernetes. And then I'm also a maintainer of Helm, so pretty excited about the Helm 3 release that we released just last week, or just earlier this week, I should say. So it's the first alpha for Helm 3, so check it out. All right, so I'm going to start with giving kind of just a quick overview of development environments, basically just what they are, and then we'll talk about specifically for Kubernetes what development environments look like, and then the tools, we'll go over the tools that you can use for development on Kubernetes. And it's just kind of a brief overview. I'm sure there's going to be lots of questions, so feel free to stop me at any time. All right, development environments. So first of all, what is a development environment? Basically, it's where you would be developing your code for your application. So you have your runtime, your framework layer in that environment, and then you have the tools that you need to build, test, and then your code. And the easiest place to go and set that up is your local machine, right? I can just go and, if I'm developing a Rails app, for example, I can just go and install Ruby, I can install Rails and all the dependencies I need to develop that inside my local machine. I can then run commands like Rails server or whatever to set up a development server and start coding. And then when I want to go and push that out to production, presumably I'm going to have some sort of Linux server running somewhere, and I'll package my app up and have that deployed there on that server. The problem is my local machine is probably going to be quite different to where I'm deploying in production. So if I have a Linux server somewhere in the cloud, my local machine's a Mac, that's obviously one huge difference. I could be using Linux, but even then, I'm going to have a desktop environment, whereas my Linux server is typically going to be a more minimal environment just for running my application. In a team of people, we all might have different environments, right? I might have a Mac, a coworker might have a Linux environment. So how do you keep versions of your dependencies kind of consistent and in sync? It becomes very difficult. And you kind of get these situations where things will work on your machine. They won't work on your coworker's machine, or they break in production. So why don't we just ship the thing that actually works, right? So this is where VMs and Docker comes in. So I was a big fan of Vagrant kind of before Docker took over the storm. Is anyone familiar with Vagrant here? So Vagrant kind of follows a similar concept to what we have with Docker right now with Docker files. So you have a Vagrant file which defines a virtual machine environment. And you have that in a repository, you pull down the repository, and then you run a command like vagrant up, and that will go into bootstrap a VM for you. And in that VM, and in that vagrant file, you can define exactly what version of each dependency or runtime or language, whatever, you want. So that way, you can ensure everyone in your team is working in the same environment. Also, if I'm deploying to a production server that's, Ubuntu 16.04, I can make sure that the VM I'm developing on is also Ubuntu 16.04. So at the OS and package, system package there, I'm also kind of quite close. The problem with VMs, though, is that if you're working on multiple services, things become a bit more difficult to handle. You probably don't want to run a VM for each of these services. It's going to probably have 4 beefy VMs running on your local machine, and you might not have the resources to handle that. Multiply that by 10, or however many microservices you might be dealing with, that obviously starts to become insane. So this is where Docker comes in, and Docker is pretty nice for this. It's much more lightweight, obviously. Containers are much faster and quicker to spin up and tear down. So it kind of becomes the perfect use case for developing these kind of services where you have multiple different things that are isolated and connect together. So if we're developing with containers, most likely we're probably going to be deploying to a Kubernetes environment. That is pretty much the de facto place now to run containerized workloads in production. So what does developing on Kubernetes look like? Well, you might be familiar with something like this. So, they're just containers, right? I can set up an environment locally on my machine and develop things with Docker Compose. It's a pretty nice way of orchestrating different services. This is an example from the Monocular project, which is a Helm project. And you can see there's a few different services here. There's a Docker Compose file that we use in development to put it together. But what I'm doing here is kind of replicating some of the stuff that I would use in my Kubernetes deployment. So I have config maps that I'm mounting in here, secrets that I'm just pointing to in my as environment variables. Got service discovery. Just by these kind of service name definitions here, I can point to different services. And I've got volume. So I've got all the stuff that I might use in Kubernetes already, and I can just replicate it here. The problem, though, is you then have to maintain this other file, and you're kind of, it's separate to what you're deploying in Kubernetes. So every time, you want to change an environment variable or change a config map or something, or a volume, you have to go and change that in multiple places, which is a bit annoying. The other problem comes in if you are using specific features of Kubernetes that aren't really supported inside of Docker Compose or require you to go out of your way to implement them differently. So as an example, for my database service, I might want to have some sort of migration run before the database actually starts up. And in Kubernetes, I can do it with a init container, which is Kubernetes provides a way for a series of containers called init containers to run in serial and complete before the main containers in the pod get start up. And so I can do that within containers in Kubernetes. I can't really do that in Docker Compose. I'd have to set up an entry point or some other container. I have to design a container that can actually do the thing before it starts up the main service as one container. There's no way to define a container that starts up before another one in Docker Compose. Another example is ingress. Kubernetes has sort of built-in support for ingress. At least it has for the definition, but then I can install an ingress controller and have that ingress actually be realized. If I want to do something like that in Docker Compose, I'd have to set up an Nginx pod and then, an Nginx container, and then mount in some Nginx configuration that I write in there, and have to to manage that manually. I might also need to have a job that needs to be run on some sort of schedule. And Kubernetes has a built-in concept called cron job, which allows me to set a job to run on schedule, and that will start up pods and do the thing. I could replicate the exact same thing in Docker Compose, but I might have to run a Docker container that has cron and can run something on that same schedule. But again, I have to have another container now just to do that. So yeah, I mean, I know how much we all love YAML, but I don't love YAML enough to maintain two different configurations at the same time. The other example is if you're developing Kubernetes extensions, so hopefully some of you are familiar with Kubernetes CRDs, custom resource definitions, and controllers, which allow you to basically extend the Kubernetes API with a custom API, so you can provide some sort of abstraction or interface for doing something new. As an example, I could create a serverless function API and extend Kubernetes with that so that it understands bits of function code like that. And then the controller can then pick that up and talk to the Kubernetes API to create pods for me. In order to develop something like this, I would actually need a Kubernetes API to talk to. There's no way to replicate this sort of thing inside just Docker Compose. All right, so clearly we need some way of developing on Kubernetes. Thankfully, I think this problem has been around for a while, and with Kubernetes kind of maturing, a lot of the development tools for Kubernetes are growing. The space is growing, and the tools themselves are maturing as well. So let's take a look at the landscape. The first thing you need is a Kubernetes cluster, a Kubernetes environment to work with in the first place. And so hopefully most of you are familiar with something like minikube. And minikube just went 1.0. The screenshot is old, but as I said, some of these tools are maturing. So if you haven't heard of minikube, it's a really easy way of getting a single node Kubernetes environment running on your local machine. So you just download minikube, and then you can run something like minikube start. It uses VirtualBox or whatever other provider you have to spin up a VM, and it will configure it as a Kubernetes environment. And then it'll also update your kubeconfig and everything to point to that minikube VM that you just set up. It also has some nice add-ons if you want to quickly install the end-to-end English controller or the dashboard. It can all be done using the minikube command line, so it's pretty neat. The other thing that's useful with minikube is if you want to test out some alpha features of Kubernetes that you aren't able, the only way to enable would be to set a flag on the API server command line. You can do that with minikube, so there's flags that you can give to minikube start to enable that sort of stuff, which is great in development if you want to test out some new features that are coming to Kubernetes. You can also configure what version of Kubernetes you want to launch as well. It's just using kubeadm under the hood, so it's pretty easy to do all that. Another option is Docker for desktop, and I like this option because it's pretty easy. And if you might already have Docker installed on your Mac or Windows machine, and if you have Docker for desktop, all you need to do is go to that Kubernetes pane and just click that button to enable it. The really nice thing about this is that it's using the same Docker environment. It's actually running the Kubernetes control plane inside that Docker environment as containers. But the nice thing about that is that it can reuse local images that you've built. So if you do a Docker build, that image becomes available, and you can create a deployment and have it use that image without having to pull from a registry, which is quite nice. You can actually do that with minikube as well, but you have to export the Docker environment. So you have to point your local Docker client to the environment, the Docker environment inside your minikube VM. The downside of this is obviously it's not available on Linux, which is just going to run Docker natively. There's no need to have this Docker desktop environment. And then it's not very configurable. So the Kubernetes version is determined by Docker for desktop, the version of Docker for desktop that you have. And there's no way to change it. There's no way to set extra flags that you might need. So if you need that, then you probably want minikube or something else. So there are other few options here as well. There's microcase, so if you're using Ubuntu, then that's a pretty easy one to install. You can just install it as a snap. It installs all the tools and binaries related to the cluster under this prefix of micro-Ks, which I kind of don't really like. It's nice because it keeps things separate, but at the same time, it's a little bit annoying if you're copying around commands and you need to replace it with micro-Ks, or you set up an alias or something. And then another option is Rancher K3S, which is a really lightweight Kubernetes distribution. Actually, it's supposed to be pitched for IoT devices, and it's a production environment of Kubernetes. But it works pretty well in development because there's the Docker Compose file in the repository that you can just use to spin up a cluster in Docker. So it works pretty well. So those are the options. Then, of course, there's remote options, so you can use one of the many managed Kubernetes services. This is an example of GKE. And this is nice that it's really easy to spin up and tear down. You just go to a UI or something, or you just use the CLI to spin stuff up. And these are production Kubernetes distributions. So this is actually where you might be deploying to production ultimately. So it's as close, again, getting back to that goal, getting as close to production as possible, that might actually be useful for you. And then you get kind of features like having public load balancers, storage through EDS volumes or whatever. Although there is limited configuration of this. So whilst you can choose kind of the version of Kubernetes that you want, again, you can't really easily enable alpha features or other things that you might use. The other option is to have a shared development environment inside your team, and we actually have this at Bitnami for certain use cases. And the nice thing about this is that they're kind of long-running clusters that are just there for any developers to use. They're managed by the infrastructure teams, and you can set it up to have load balancers that are only accessible over VPN, so it becomes very easy to share what you're working on with other teammates. And again, because this is something that you're setting up as a team, you can tune it to match your production environment as close as possible. It can be easy though to tread on each other's toes if you don't have the right level of access control through RBAC. It can be easy for people to accidentally write over other people's namespaces if you don't have a good way of managing that. All right, so we have a Kubernetes environment, hopefully. We've chosen one of those options. So now, I actually want to develop my application. So, hopefully this cycle is familiar to you. When you're developing an application, you're going to want to build some number of container images, push them to a registry, and then update the deployment. When you want to change some code, you're going to rebuild it, push it up to a registry, potentially, and then update the deployment again to have that change reflected. And that cycle continues and continues. That can be really slow and really meticulous if you have to keep running those commands every time you want to change even a small bit of code. So luckily there are some tools that help you automate the cycle. So Draft from Microsoft and Skaffold from Google are two tools in that space that come to mind. In the case of Draft, it kind of has a kind of pass-like feel. It's from the team that work on data, so it's not really that surprising. But basically, you go into a directory and then you run a Draft command and it will automatically generate a Docker file for you based on what type of application you have and a Helm chart to go and deploy it as well. And then you can go and modify those things afterwards as you need. And then there's different paths that are used to define those different configurations. Skaffold is a little different in that it works with any directory that contains a Docker file. So you already need a Docker file in that repository for Skaffold to work. But it's a bit more flexible. You can plug it into different pipelines. So one thing that's pretty nice is that it integrates directly with the Google Container Builder. So if your builds take a really long time, for example, and you want it to push up to GCR or something afterwards, you can hook it up to this remote build service, which might make things a little faster for you. The other nice thing is that it's a bit more flexible and that it works with any deployment tool. So it doesn't have to just be Helm. It can work with just raw kind of QTCL manifests or some other tool that you might use. But again, you're still having to build Docker images here, which can take some time. It's kind of the new compiler, right? So is there a way we can do this faster, especially if you're working on some front-end applications? I've worked on applications that are React-based, and just building those every time takes a very long time to compile. So there are some other options for that, which is great. So one of the nice things with these React applications is that you tend to have a Node.js development server that you can run on your local machine, and that will watch for changes, and then just compile the parts that are necessary, and then you can just refresh the browser, and those changes take effect immediately. So some of these toolings have development servers, so we can use that. One tool that I use quite a lot is Telepresence, which is part of the CNCF now. And what it basically does is it takes a deployment that's already running in your cluster, and it will replace it with a two-way proxy. And then it will proxy all connections going to those pods to your local machine. So then you can run a local process on your local machine, and it can accept connections from the cluster as if it was running inside that cluster. It also sets up your local machine with the environment variables that were existing in that pod, and it sets up, it will mount volumes inside your local machine as well that are also in that pod. And then you also get service discovery, so it sets up a tunnel, a VPN tunnel, or I think it has a few different other methods as well to enable service discovery. So now from my local machine, I can talk to different services that were in that Kubernetes environment. So all in all, it acts as if that thing was running inside my cluster. But I can then run my development server, I can have it go into port 3000 or whatever, and then when I make changes, I can see those changes reflect. I can talk to other services that are deployed inside that cluster, and it just all works seamlessly. Another option here is something that's pretty new, which is cloud-native development from the folks at Optito. And it works in a similar way to Telepresence, but it effectively runs the development server inside a pod in the Kubernetes cluster, and then it will sync local file changes with that pod. So it kind of does it the other way around. The downside of that is then all the kind of tools and debugging have to happen already, whereas with Telepresence, because everything's running on the local machine, it's a little easier. You just need to have all your tools locally to do all that. So we talked about building, and I think so we talked about building Kubernetes extensions, and there are some tools in this space as well that help you develop them. So first of all, Kubernetes controllers are usually written in Go. That's just because Kubernetes itself is written in Go, and all the libraries have to also be written in Go. And the way controllers work is they watch Kubernetes API resources, and then when something changes, they kick off a handler to reconcile the state and have something happen. So a couple of tools that you can use to build Kubernetes extensions. So there's Kube Builder, which is part of API machinery. And again, this is a tool that you can install locally. You can run Kube Builder, and it'll set up a scaffold out environment for you to start building a controller and a CRD. And then there's also the Operator SDK from the folks at CoreOS, Red Hat, IBM, whichever you prefer. And it works in a similar way to Kube Builder, but it focuses on the operator concept, which so operators. Okay. So operators are similar to the whole controller and CRD model, except they also focus on a particular application, and the idea is to codify logic to manage that particular application, have it build in logic for upgrading it, scaling it out, and backing up and upgrading. So things like etcd, for example, where it becomes difficult to manage that with just the Kubernetes workloads API directly, the etcd operator can handle etcd clusters. Another interesting project here is MetaController, which takes a different approach for building controllers. You actually don't have to write them code. It kind of takes a more serverless approach, so you can write them in kind of any scripting language you prefer, so like Python or JavaScript, I think is supported. And it basically calls a handler whenever your CRD or resources change. And then that handler can then return a response, and then MetaController will apply it to the API server. So I think I like that one because it takes a different approach to it. I'm not going into too much detail here because building controllers and operators is a whole different talk entirely, but this is just an overview of tools that you might want to look into. So that's kind of all I have. Here are some links if you're interested in finding out more about this stuff. So the Bitnami documentation is kind of a plug, but we have some good documentation there about both deploying and managing applications as well as building applications and developing applications in Kubernetes, so check that out. And then SIG-Apps is also a really good place to get started if you're interested in just hearing how people are developing and building applications. I want to find out more there. And then of course, all the tools I've kind of gone through, I'll share my slides, but they all have project pages where you can find out more about it. That's it. Yes?
And tips for developing Kubernetes controllers locally?
Locally. Yeah. So the question is, any tips for developing Kubernetes controllers locally? So I guess I should say what I usually do, which is kind of similar to the Telepresence approach, where you have a Kubernetes cluster running and you deploy a controller there. I basically just will run that controller locally and point it to my kubeconfig to have it work inside that cluster. That may not be the best approach. You might want to use something like Telepresence to replace the controller, or use something like Skaffold as well. Both those tools work in that case. The one problem with Telepresence is that if you're trying to use, so one thing that's useful with controllers is being able to mount the service scan. Excuse me. The problem with Telepresence is the place that it mounts it in is in a different location to where the client Go expects it to be. So that becomes a problem. But if you use something like if you use something like Skaffold, then it will just be able to build that pod when you build your controller, and then just deploy that. Sometimes with some of these things, it's just easy to run it locally. So as long as you can point it to you can. Any other questions? Cool. Okay, thanks.
So we have a small break now. Till 11:35.